MS Ramaiah University of Applied Sciences.
Hello students, let us have a discussion on open circuit and short circuit tests on single phase transformer. The objectives of this laboratory experiment are to conduct open circuit and short circuit tests on the given single phase transformer, to determine equivalent circuits in terms of low voltage and high voltage, to obtain voltage regulation and efficiency. Introduction. Transformer is a static device that changes AC electric power at one voltage level to AC electric power at another voltage level through the action of a magnetic field. Transformer works on the principle of Faraday's laws of electromagnetic induction. According to the statement of Faraday's law, rate of change of flux linkage with respect to time is directly proportional to the induced EMF in a conductor or coil. Theory. Purpose of conducting open circuit and short circuit tests on the transformer is to determine the parameters of the equivalent circuit, to predetermine the voltage regulation and efficiency at any given load. Theory of open circuit test. Open circuit test is usually conducted on the low voltage side. Open circuit test is used to find no load loss or core loss, no load current I0, which is helpful in finding R0 and X0. Theory of short circuit test. Short circuit test is usually conducted on high voltage side. Short circuit test is used to find full load copper loss, to predetermine the efficiency ZO1 or ZO2, XO1 or XO2, RO1 or RO2, to predetermine the voltage regulation. These are the formulae needed to calculate the circuit parameters of the single phase transformer. Percentage regulation of the transformer is calculated using the following formula. Computation of efficiency of the transformer is carried using the following formula. To verify this experiment, we need 2 voltmeters and 1 ammeter with suitable ranges, 1 low power factor wattmeter, 1 unity power factor wattmeter, single phase auto transformer, single phase transformer and connecting wires. This is the experimental setup of open circuit test. This is the experimental setup of short circuit test. Discussion. Calculate the power for 3-phase system and show that the algebraic sum of 2 wattmeter readings is equal to the total power dissipated in the 3-phase circuit. Comment on your results. Applications. These tests are used to test the manufactured transformers.
Hello students, let us perform OC and SC test on a single phase transformer. Tests on single phase transformer are basically conducted to find out the losses in transformers. Losses in transformers are classified into 2 types basically. One is iron loss and copper loss. Performing this experiment, we are trying to find out the copper loss and iron loss in the transformer. Equipments needed to conduct this experiments are voltmeter, ammeter, LPF wattmeter. Cos phi value will be mentioned on LPF wattmeter, UPF wattmeter, auto transformer, single phase transformer and connecting wires. This is multimeter. Now let us discuss about the components that is being used to conduct this experiment. This is voltmeter. Voltmeter is a device used to measure voltage. This has 2 terminals. These 2 terminals are always connected in parallel to supply. Voltmeter is available in different ranges. This particular voltmeter ranges from 0 to 300 volts. This instrument is ammeter. Ammeter is basically used to measure current. Ammeter has two terminals. These two terminals are always connected in series with the circuit. Ammeters are available in various ranges. This particular ammeter range from 0 amps to 5 amps. Now let us discuss about wattmeter. Wattmeter is a device used to measure the power consumed by any equipments. Wattmeter are basically of two types. One is LPF wattmeter and the other one is UPF wattmeter. The cos phi value will be given for LPF wattmeter, whereas it is 1 for unity power factor wattmeter, hence it won't be mentioned on the wattmeter. The wattmeter are also available in various range. As you can see here, this wattmeter ranges from 0 to 1200 watts, whereas here it varies from 0 watts to 6000 watts. The terminal connections of the wattmeter are seen here. This 4 are used to set the current value of the wattmeter as per our requirement. There are M, C, L and V. MC should always be shorted for wattmeter. L is line which is always connected in series, which is called as current coil of the wattmeter. V, we can select the range based like 300 and 600 volts. Potential coil is always connected in parallel to the circuit. 300 and 600 are the ranges that need to be selected for voltages. This connection will remain same, any one can be chosen. This is auto transformer. Supply for auto transformer is 230 volts 50 hertz supply. Auto transformer is a device where input is constant and you can obtain variable output voltage ranging from 0 to 270 volts as per this auto transformer. There are two output terminals, that is phase and neutral. Transformer is a static device which change power from one voltage level to another voltage level, keeping frequency constant. Transformer basically has two terminals, primary and secondary. Primary and secondary both has two terminals, phase and neutral. This transformer rating is 1 kVA. The secondary voltage level is from 0 to 115 volt and primary voltage level is 0 to 230 volts. This is multimeter. Multimeter is a device used to measure multiple variables. You can measure resistance, voltage, current, capacitance and also find out the connectivity of the circuit. You can measure resistance from 200 ohms to 200 mega ohms. You can measure DC voltage from 200 millivolts to 1000 volts. You can measure AC voltage from 2 volts to 750 volts. You can measure AC current from 2 milliamps to 10 milliamps. You can measure DC current from 2 milliamps to 10 amps. You can also measure the capacitance value. This is common point. The black wire should always be connected to common point. If you want to measure voltage, then it has to be connected on V terminal. If you are measuring current in few milliamps, it has to be connected in milliamp position. If you are measuring current in few amps, then the red knob has to be connected in 10 amp position. These are connecting wires. Connecting wires are used to connect the circuit. Now let us start this experiment by making circuit connections. Now let us start conducting open circuit test. To conduct open circuit test, we need LPF wattmeter, voltmeter, ammeter, auto transformer, single phase transformer. Let us take those components and start building the circuit. Open circuit test on single phase transformer is always done on low voltage side. So, all the circuit that is being built for open circuit test will be done on secondary side of this transformer, that is from 0 to 115 volts. From phase of the auto transformer, the wire is connected to one end of the ammeter. The other end of the ammeter is connected to M of the wattmeter. M and C is shorted, M and C is shorted. From L terminal, it is connected to 115 terminal of the secondary of single phase transformer. From 300, that is V terminal, is connected to 0 terminal of secondary of single phase transformer. From same terminal, it is connected to neutral of the auto transformer. We have to connect a voltmeter parallel to supply. So, this completes the circuit of open circuit test. We need to apply rated voltage to conduct open circuit test. To conduct the experiment, we will place all the meters horizontally. Turn on the power supply. Make sure auto transformer is in minimum position. Seeing voltmeter, apply 115 volts. After applying 115 volt, note down the corresponding ammeter and wattmeter reading, which is open circuit current and open circuit power. Open circuit power is nothing but iron losses. Open circuit test is being conducted, all the readings are tabulated. Now let us make circuit connection for short circuit test. These are the components needed to conduct the short circuit test on a single phase transformer: auto transformer, multimeter used to measure the applied voltage, ammeter to measure current, wattmeter to measure power consumed or to find out the copper loss. A single phase auto transformer, the entire circuit is made on the high voltage side. So, the circuit is connected on the primary side of the single phase transformer. Now, let us start the circuit connection. From face of the auto transformer, it is connected to first end of the ammeter, other end of the ammeter is connected to M of the wattmeter. M and C is shorted. From L of the wattmeter, it is connected to 230 terminal of the transformer. V terminal, that is 300 terminal of the wattmeter, it is connected to 0 terminal of the transformer. From same position, it is connected to neutral of the auto transformer. The voltmeter connection is taken by multimeter, which will be connected across supply while conducting the experiment. To conduct short circuit test, we need to short the secondary terminal of the transformer. Now let us start conducting short circuit test. Before conducting, we will place all the meters horizontally. For short circuit test, we need to apply rated current. So, seeing ammeter, apply voltage till ammeter reads 4.2 amps. Make sure auto transformer knob is at minimum position. Turn on the supply. Seeing ammeter, apply 4.2 amps. Note down the wattmeter reading and measure voltage using multimeter. Bring back auto transformer knob to minimum position and turn off the supply. Tabulate all the readings, carry out the calculation. This completes open circuit test and short circuit test on single phase transformer. Now calculate efficiency and regulation of single phase transformer from the obtained values.
At MSR UAS, we spark your imagination unlike any other.